So I have a Hydro Flask, and I think it's awesome. It keeps my hot drinks hot and my cold drinks cold. But I want to quantify how great it really is, so I'm going to conduct an experiment and collect some data, and I'll explain how it works.
In this experiment, I'm going to test a Hydro Flask against an NALGENE water bottle. To make it easier, I made sure that the two bottles had the same volume and more or less the same shape, or surface area. I didn't want to mess up the data at all, so the test was done at the same time in a room set at 70 degrees. How it works is I filled up the bottles with cold water that had been sitting in my fridge overnight, and I took the temperature of the water every 15 minutes. After a while, we should be able to see how the water temperature changes over time.
So before we get into the results of the experiment, I need to explain a little bit about heat transfer so we know what's going on exactly between the NALGENE and the Hydro Flask.
There are three ways that heat can be transferred: convection, conduction, and radiation. Convection is the heat transfer in fluids, so in this case it would be the outside air coming in contact with the water inside the bottle. The NALGENE does a pretty good job of stopping this by having a screw-on lid blocking any of the air from coming inside the bottle. Next is conduction, which is the heat transfer from one object directly to another. And the NALGENE doesn't have anything stopping the bottle from transferring the heat to the water, so as the plastic heats up, that heat will go directly to the water. So last is radiation, which is the heat transfer by electromagnetic waves. Everything emits radiation, and what's different about it is that it doesn't need material to transfer heat, and the NALGENE bottle absorbs a lot of the radiation that it comes in contact with. Now let's take a look at the Hydro Flask. And just so you know, every vacuum insulated bottle is a little bit different, but in general they use the same technology. To reduce convection, the Hydro Flask uses a plastic screw-on lid just like the NALGENE, but the difference is that the Hydro Flask uses a rubber gasket on the inside of the lid to create an airtight seal, so that makes it even more efficient. To reduce conduction, the Hydro Flask uses an outer barrier, and between these walls there's a vacuum. So since there's no air in between the walls of the bottle, no heat can be transferred by conduction or convection. So the last one standing is radiation, and the Hydro Flask actually does a really good job of getting rid of that too, because the inner walls of the bottle are coated with a super reflective finish, so that any radiation that it comes in contact with, it just bounces off the walls instead of being absorbed.
So after all that, you can predict that the total heat transfer in the Hydro Flask is going to be a lot less than in the NALGENE, and the data from the experiment definitely shows that.
If you remember, the experiment was done in a room set at 70 degrees and the water started out at 40 degrees. After taking the temperature of each bottle every 15 minutes, it took 5 hours for the water in the NALGENE to warm up to room temperature. It shouldn't be a surprise that the Hydro Flask did a lot better. After 5 hours, the Hydro Flask's water only changed by 6.5 degrees, so that means in this experiment, the Hydro Flask was 82% more efficient. If we were to extend this experiment out, we could safely say that it would take well over a day for the water to reach room temperature.
Now remember, this isn't just for cold water, it's for any liquid, cold or hot. So if we were to do the experiment again with a hot liquid, it would behave similarly, just flipped. So after all said and done, I'm not trying to say don't go out and buy a NALGENE. Really, I use my NALGENE regularly. But what I'm hoping is that you found this interesting and that you learned a little bit about the technology that's used.